Hey, so the focus of this is looking at what we call sinusoidal functions, so variations of sine and cosine or wave functions, and using them to model more and more. And I have some review here about amplitude and period and things we've seen before. So let me just get straight to this one here. So I have in blue, we don't really need it, but I want to use it at times to visualize. I have a sinusoidal function f of x, minus 3 sine of 2x minus 1. And I want to find the amplitude, period, and principal axis of f. So the amplitude, which is a measure of the vertical distance from the center line or the principal axis to either the max or the min, I can see from right here, it's not -3, it's the absolute value of -3, or it's just +3. The negative doesn't affect the amplitude. And so, again, the amplitude is, it's the absolute value of -3, or in this case, just 3. Keep in mind, amplitude is never negative. So it's always related to that value. Quite often we use a parameter of a to represent, in this case, what's -3, but amplitude is always a positive. The principal axis, that is the horizontal line with which the function oscillates evenly up and down above, that is the same as the constant value right here. And so the principal axis is y equals -1. And now I have those then. If I look back at this visual, which I didn't really need, but the principal axis, if I just draw this right here, it's at -1. And notice, if I'm careful with my ruler, that's kind of careful. Notice that evenly breaks my function at half above that horizontal line, half below. And that amplitude, I can now see, again, the distance from there to there. That distance is 3, whereas this distance is also 3. Right, that's the amplitude. Although, again, I can see it from the equation. I don't really need the graph. The last thing I want to find is the period. So the period is a measure of one horizontal cycle. Again, it's a distance. It's always positive. It's a little tough to tell from looking at the graph. It's for example, it's a horizontal distance from there to there. Or I can say it's a horizontal distance from here to just off my graph. It's always the same thing. From this, what's a little helpful to remember is what I have up here. The period is always the same as 360 degrees, if we're thinking in degrees, divided by that b parameter. Or the other way around, the b parameter is always the same as 360 degrees divided by the period. So notice that b parameter, this right here, if it's sine, or right here, if it's cosine, is not the same as the period, but they're always related to it. So if I look here, that goes back to my 2. So the period is not 2, but the 2 affects the period. So in this case, the period is the same as 360 divided by 2, which is in this case 180. And that's my period, which means I now know the distance from this point here to this point here is 180 units. All right, so here I have a different function. It's 4 times the cosine of x over 5 plus 1/2. So again, the amplitude I can see is just 4. The principal axis I can see is positive 1/2, or y equals positive 1/2. And the period is related to this divided by 5 here. Now, before I get to that, let me do a little bit with the equation. It's the period is. If I look at this equation, the period will be a little easier to figure out if I rewrite it into a different form. If I write it like this, 4 times the cosine. Instead of x divided by 5, I write it as 1/5 times x, which is equivalent. It makes it more obvious, perhaps, how I found my period, because that b parameter I was using before is not 5, it's 1/5. That b parameter I refer to up here is what's being multiplied to the x, not divided. And so in this case, instead of thinking of it as being divided by 5, x being divided by 5, x is being multiplied by 1/5, which is equivalent. And so my period is 360 not divided by 5, it's 360 divided by 1/5. which is equivalent to 360 times 5, which is 1,800. So again, the period is not 1/5 or 5. It's related to that value. The period is 1,800. And so again, if I look at my graph, I now know the horizontal distance from here to here is 1,800, which actually I could tell by looking at my graph. I looked at it in detail, but again, I don't need to. All right, so here I have a cosine function with a couple parameters, a and b. I want to figure out the parameter for a and the parameter for b. One thing I would do is if I want to see what the amplitude is, or a related to a, I know what's going to be the same as the distance from the max to the min, but divided by 2. So it's the difference from 2 to -6, which is a difference of -8, but chopped in half, which is -4, but it's always positive, so it's +4. Or another approach that's not so talky is to draw my center line, or my principal axis, which I can see must be at -2, which again is halfway between the max and the min. -2 is halfway between 2 and -6. And my amplitude is the vertical distance from there to there, or the vertical distance from there to there. Either way, however I look at it, my amplitude is 4. Right, not -4, +4. All right, so that means my A value is 4. Now, I will say one thing, because there is a chance, while my amplitude has to be positive, there is a chance the A parameter is negative. If the A was a negative, then if I look back here, that would mean my wave, my cosine function, would behave more like this, what you see in blue, in which the wave would start at the minimum and then go up and then back down. However, if I look here, if I look at 0, my wave is at the maximum and starts at the top and goes down and back up. And that's how I know my A parameter is a positive. If that A parameter was -4, this whole wave would be reflected, and it would look something more like this, my quick little sketch. This here, if my graph looked like that, then my A parameter would be a -4, because when x is 0, my wave is starting at a minimum. But it's not, so that's good. Keep it a little bit more simple. My B parameter, for this I need to figure out the period, because B is always the same as 360 degrees divided by the period. So what's the period? Well, I can look at my graph. The period is the horizontal distance from here to here, which I can actually see is 90 degrees. And so my period is 90 degrees, which means I can see my B parameter quite quickly. I get 360 degrees divided by 90 degrees, which is exactly 4. So that B parameter is 4. Which means my equation, I now know, is y equals 4 times the cosine of 4x minus 2. So in this case, both my A parameter and my B parameter were +4. All right, so for the last one, I'm describing some features of a Ferris wheel, and we want to use this to create an equation. So this Ferris wheel in Dubai is the largest in the world, at least at the time of me recording this video. It has a diameter of 250 meters. Passengers get on at the bottom, and one full ride takes 38 minutes. So first, to make a quick little visual of what's happening here, let me make a basic sort of sketch, which I have on my x-axis. And I know we start at the bottom, so when time is 0, I know it takes 38 minutes to come back to the bottom, so 38 here. I know the diameter is 250, which means the maximum height a person must reach is 250 meters, because we start at the bottom. And so I now, and I guess as well, because this forms a wave, I know halfway between getting on and getting off, which in this case is at 19, it must reach its maximum. So I know this must look something like this. So here's my little sketch of my sinusoidal function. 1 full cycle. All right, and while I'm at it, it's helpful for me to draw the principal axis, which is halfway from the middle to the top, which must be 125. Because that there will tell me what my D parameter would be, or the constant parameter. And now that I have that, I can see my amplitude. My amplitude is the distance from the middle to the top or the middle to the bottom, doesn't matter. Either way, my amplitude is 125. Actually, I'll say amplitude, not A. So let me write some of these things down. Amplitude equals 125, and my principal axis is also 125. So in terms of my equation, whether it's sine or cosine, I know 125 for the A parameters it's going to be related to, and 125 will be my D parameter. Well, I need to think about my B parameter, which is related to the period. So B, as we've seen before, is the same as 360 degrees divided by the period. Well, in this case, the period is the time it takes for 1 full ride. So it's 360 degrees divided by 38 minutes, which I'll just write as a reduced fraction, which is 180 over 19. I want to be exact, and my decimal is not terribly pleasant. So now all that's left is to think about, okay, is this going to be a sine or a cosine function I want to use? I can do either, but one is going to be a little easier. And is it going to be negative or positive? By that, I mean you may be tempted to go write something like this. Y equals 125 times the sine of 180 over 19x, or I'll put t for time, plus 125. I say you may be tempted to go to this because it is going to be wrong, but that there, if I go back to the very top of the notes, kind of relates to this sort of form here. But we should have really 2 questions here. First, how do I know it's not a cosine function? And both could be used. It depends on the details of each and what's a little easier to work with. And as well, how do I know A is positive? Because A doesn't have to be positive. I know that D, my principal axis, is a positive 125. So to kind of help us understand what's happening here, let me graph this. I want to graph this function I see right here. 125 times sine 180 over 19t plus 125. And that's what I see here. Now let me adjust my scales. Right now my scales are terrible. I want my y-axis to represent the height of the Ferris wheel, which goes up to 250 meters, and x-axis is time, which should go to 38 minutes. So if I look at this, this is 125 times the sine of 180 over 19x plus 125. Notice in this case, at time 0, we're already halfway up, and then after 38 minutes, we're back to being halfway up. And that's because a sine function starts at the center line, which we can kind of see in our notes right here. A positive sine function, I see here in red. It starts at the principal axis and then goes up. And so I don't want to, if I look at this, you get on at the bottom. So you may be tempted now to use cosine. If I use cosine, I have this, in which my wave now starts at the top, which is not how, that means this would make sense if you got on at the top of the Ferris wheel, did 1 full cycle all the way around, and then they kicked you off at the top again. We're getting there, but that's wrong. And that kind of goes back to, again, right here, where a positive cosine function, as you can see in blue, starts at the maximum. We want to start at the minimum. We get on at the bottom. So of all of these here, I want to look at this one right here. Imagine a cosine function with a negative reflection in the front, because then my wave starts at the bottom, which means my function here, I don't want sine, I want cosine, because cosine is what I can use to start at the bottom, but I don't want positive 125, I want negative 125, which will reflect that around. And so as if I just go back to my visual, again, this was positive 125 cosine, this is negative, this is what I want. And notice if you look at these 2 waves, they are reflections of each other, but if I turn off the old one, this now matches up with my idea of starting at 0, reaching your peak 19 minutes in, and the kick you off unless you pay for another ride. 30 minutes on. And so thinking about whether it was sine or cosine depends on the features of the wave. All of these, if I graph all of these, they're all different. They're all related. They all have the same amplitude. They all have the same period. They all have the same b parameter. They all have the same principal axis, but they're not the same wave. And that last part tends to be pretty challenging to think about which function should we use and what the parameter should be negative or positive.